Okay, peeps, here we are with the last section on lesson 15.5. This is the last section of the school year that we'll be talking about. So we're going to go ahead and scoot to you. We're going to get to part one. And again, calculator is going to be needed here, so you might want to go grab one. We're going to be talking about finding what they call the MAD. Okay, the MAD. And so the MAD basically stands for, as you can see right here, the mean absolute deviation. Mean absolute deviation. Now again, if you look at that as a whole, kind of confusing, but if you look at it as parts, mean obviously is average. Absolute means it's going to be positive because we're going to take the absolute value of numbers. And deviation means how far from a particular stack, all right? In this case, the mean, all right? So we take a look at what we've got here. Everything's going to be, or I shouldn't say everything, most things are going to be in this dot plot format. And the first thing that you're going to want to do is you're going to find, so follow this process right here. This is going to be key. You're going to want to write down these steps, 4 of which, and again, actually, I'm going to probably jump from step 2 to step 4. I'm going to do this absolute deviation all kind of at the same time, all right? So steps 2 and 3 for me are going to kind of be combined, I guess you would say. So the first thing we've got to do is we have to find the MAD, all right? And in order to find the MAD, you have to, first of all, step 1 is to find the mean. And so you can see here that we have a series of numbers. We have 7, we have 8, we have 8, we have 9, we have 10, we have 2 11s, and we have 2 13s. So we're going to have to find the average of those numbers. Okay, now recall, in order to find the mean or the average of those numbers, we're going to add those numbers together and then divide by the number of data points. This is why you obviously are going to want a calculator close by. So we take a look at that. We're going to see that 7 plus 8 is 15, plus 8 is 23, plus 9 is 32, plus 10 is 42, 42 and 11 is 53, 53 and 11 is 64, 64 and 13 is what, 77, 77 and 13 is 90. So my sum here is going to be 90, and then I'm going to divide it by the number of data points that I have, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 90 divided by 9, the mean is going to be 10. Okay, the mean is going to be 10. So when I say that the mean is 10, as they verify with me right there, then we're going to go ahead and take a look now at the deviations. What the deviation means is how far are all these data points away from 10. So with this being the key, all right, and obviously this is going to be a 0 because you have 1 point right on the mean. How far away is 9 from 10? And this is where I use the absolute value of it. So I'm going to go ahead and combine, as I told you, steps 2 and 3. So 9 is 1 away from 10, 8 is 2 away from 10, 8 is 2 away from 10, and 7 is 3 away from 10. 11 is 1 away from 10, 11 is 1 away from 10, 13 is 3 away from 10, and 13 is 3 away from 10. So we're going to find all those. What we just did was found the absolute deviations, and now you're going to find the mean absolute deviation. So once again, you're going to have to say, add up all those numbers I just printed out in red. So if I go 3 plus 2, that's 7, 8, 9, 10, and then 10 and 6 is 16. So I'm at 16. I'm dividing that by 9. All right, again, the number of data points. You still have to include this data point right here, even though it was 0. So 16 divided by 9, the result is about 1.8, okay, as far as the mean absolute deviation. Now, what does this actually mean? It means that the average number distance away from 10 is 1.8. So if I took 10 and I subtracted 1.8, I'm going to get about 8.2. So about right in here. Okay? And if I went 10 plus 1.8, I'm going to get 11.8. Okay? And so 11.8 is right here. And so they're going to basically say right here in this general area, okay, is where we're talking about the mean absolute deviation. Okay? All right, go ahead and click on that. You see that, and then you can see that they purple that in for us. Questions? All right, so obviously this is used in a lot of data collection, you know, numbers in regards to business uses this type of stuff a lot. Science would use this type of stuff a lot. Let's take a look, let's watch a little clip, video clip here. Right, and so what they're going to do here, basically, and they do you a favor, they ask you to calculate the math for the heights of second grade kids. And they're telling you that the mean is about 50 inches. Now, so there's the good news. They gave you the mean already, so they already did step one. Now all you have to do is find out how far these numbers are from 50, how far they deviate from 50. And again, I'm using absolute values here. So here we go. Let's start on the inside. How far is 49 from 50? Well, this is going to be 1 away, 1 away, 1 away, 1 away, 1 away. This is going to be what? 2, 2, 2. And this is going to be 3. And then what? Over here we have a 43, so that's 7 away. Obviously, these are going to be zeros. These are going to be 1s. These are going to be 2s. How far are these? These are 3 away from 50. This is 4 away from 50, and here's another 7 away from 50. Okay? So we then have to take all those red numbers and add them together. All right, so here we go. 7, I'm going to start on the left-hand side here over here. So 7 and 3 is 10, 12, 14, 16, 17, 18, 19, 20, 21. Don't have to add the zeros in. 22, 23, 24, 25, 27, 29, 31. 31 and 3 is 34. 34 and 3 is 37. 37 and 4 is what? 41. 41 and 7 is 48. So it appears as though all the deviations add up to 48, divided by the number of data points that I have then. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay. So we're going to take 48, we're going to divide it by 25. 48 again divided by 25 is 1.92. And they want us to round to the nearest whole number. So that's going to be, and this is where I use my little lasagna looking equal sign, about 2 is your answer. Okay? Again, just to verify that our answer is correct, we went through the same process that we did, and they got 48 over 25 just like I did, and they got 2. So mean average deviation for the heights. The average second grader is about 2 inches either side of 50 inches. Okay? That's basically what it means. Questions? All right, move on to, and this one's going to be just very, very similar in terms of how we're going to process it. So I'm going to skip that one, I believe. We're going to move on to this one. They show the height distribution of a second grade kid and a 7th grade kid. Why are the maths of both samples exactly the same? And again, the fastest way to probably look at that is to take a look. And again, we just in essence did the 2nd grade group, and the 7th grade group is the one we just skipped. And so it simply says that the shape of the figure and the distribution, okay, of the points is similar. So that means that their mean absolute deviation should be about equal. Even though you look at this and say, well, hey, the 2nd graders are, the mean was 50, and over here the mean was 61, that really doesn't have anything to do with it. It basically means how far is each of these approximately from, and so this one we said was about 2, all right, and so we're going to say this one's about 2 as well, okay? All right, moving on then to my key concept, I believe is coming up next. All right, so these guys are going to roll through this.
Suppose you have a data set A with mean X and mean absolute deviation M.
Now we're going to come up with another data set.
Suppose you also have data set B with mean y and mean absolute deviation m.
So we have two groups very similar to our second grade group and our seventh grade group from the prior screen.
When two data sets have approximately the same variability, you can use their mean absolute deviation to describe the distance between their means. You can express this distance as a multiple of the mean absolute deviation. The centers of data set A and data set B are about 4 mean absolute deviations apart.
Now, remember, one thing that they gave you already in this is they basically looked at this and said, hey, from here to here and from here to here is about 1 mad. Okay, same thing in this blue set. If you look at from here to here and you look at about here to here, then each of those is about 1 mad away. Okay, so that's what we're talking about if their variabilities are similar. And so we're trying to look at that and say, hey, how many of those mads are in between these two points? So if you take a look at that and say, hey, here's 1 mad, 2 mads, 3 mads, 4 mads away, and that's how they get this number in essence. All right?
The greater the distance between the means of the data sets, the more multiples of the mean absolute deviation you need to describe that distance.
Okay, so obviously these are farther away, and now we're at 7 of these mads versus 4 of the mads from the previous screen. All right? Okay, let's see if we can go ahead and put that to work as we move into this next section. All right, so they have second grade kids at 50, or they have second grade kids with a mean of 50. They have seventh grade kids with a mean of 61. The mean absolute deviation of each set is 2. So they're already telling you that the mad is 2. How do the means compare? So if we take a look at this and say, hey, here's my 50, here's my 61, okay? And they're telling us that the mad is 2. So we're basically going to say, I'll use a different color here, that if the mad is 2, that means that, boom, right here is 1 mad. Notice it's from 50 to 52, so the length of our mads are going to be 2. Here's from 52 to 54, that's 2. Here's from 54 to 56, that's 3. Here's from 56 to 58, that's 4. Here's from 58 to 60, that's 5. And from 60 to 61 is not a full one, but is a half one. So we're saying here that we're looking at 5.5 mads apart, okay? 5.5 mads apart. And again, trust me when I say that's exactly how they're going to calculate that situation. Now again, the other way you could do it maybe a little quicker, I wanted to do it so you understood it, is you could look at this 50 and you could look at this 61, and you could say, hey, 61 minus 50, that's the distance between the two means, is 11. And if you take 11 and you divide it by the mad, okay, which in this case is right up here, 2, you're going to get your 5.5. Okay? So again, this is one thing that's going to be difficult for you guys on this situation is these are all new terms to you that you have not really seen much. All right, moving on with this next example problem here. And again, they give you all the data that you want right here in this chart, all right, where they say express the difference as a multiple of the mad of either grade. So if we simply take a look at the difference between the two means, 66 minus 61, and obviously that's 5, and then we take that 5, and we're going to divide it by the mads, and the mads in both cases are 2. In order for this to work, that's what it has to be. So we're saying the final answer is going to be 2.5, okay, 2.5. You can see here when I hit show answer, boom, right here it's mine, 2.5, okay. All right, let's move on to my last piece here. Let's see what it says. So it says, second, 7th, and 9th grade distributions have approximately the same mean absolute deviation. The means of second and seventh grade kids is 5.5 apart. The means of seventh and ninth grade are 2.5 apart. How can you use the MAD to measure the degree of visual overlap? Okay, so now we're going to be talking about this from a visual perspective. So obviously, your answer should be, hey, the closer or the smaller this number right here is, the closer these data points are going to be to each other, and therefore you're going to have what they call more overlap. All right. If the number is bigger, like 5.5 is bigger than 2.5, you're going to have less overlap, less sizes in common. Okay. For the MAD, distance between there's less visual overlap. The lower the MAD, the more visual overlap. We're going to probably see that in play here on section 3. All right, I'm back here on part 3. Have some technical difficulties with those, with Pearson bringing up the examples there. So I'm going straight to the homework. And so you can see problem 5 on your homework tonight. It's going to be very much like this. You haven't seen anything like this at this point. So here's a couple things to pay attention to. It says here we have a mean of 700 and we have a MAD of 25. Okay, those numbers are going to be important. We're going to get 7, or basically, it says sketch a second data distribution that is 4 MADs greater than the mean of the blue curve. Okay, so if I want 4 MADs greater, I'm going to take 4 times the MAD, and in this case, 4 times the MAD is 4 times 25. So I'm looking for the new mean to be at, and it's going to be greater. 700 is where we started. And so 700 plus 100 is going to equal 800. So I'm looking for the new mean to be at 800. Okay. Now, a couple things you could do. First of all, if I look at C, you can cancel C out right away because the red one is left of the blue one, so therefore it's actually smaller. You can see that our mean on the blue one that said was 700. Where is this red one at? It looks to be at about 800. So I think A is going to be our answer. If you take a look at this one, we're at 700, and it looks like the mean on this red one is at 900. So that's a 200 in there, and over here was a 100. Okay, so it wants 100. It wants to move it to 800. So A is going to be our final answer on this problem. Okay, do another one of those potentially. Get rid of this. We'll move on to problem number 6. And so when we move on to problem number 6, you can see that we're looking at a very similar type problem. Actually, it's the very same exact problem. So let me hit, let's see, which one was it? It was at 700 to 800. Let's see. Weird that it was the same exact problem. Oops. Well, maybe not. Oh, okay, I'm sorry. It's 8 MADs. So 8 times 25 is 200. So that means it's going to be the one where red is, and it says it's less, all right? So it's 200 away from 700, so it should be A, okay? My fault. Let's go through another one of those, maybe hit a similar question here. So 900 is where our starting point is. We have a MAD of 10. We want a second one that is 4 means less than 4 MAD, mean absolute deviations less than. So 4 times 10 is 40. If we're starting at 900, that means we want it to be at around, 860? 860. So if I look at this dude right here, it looks as if that guy right there, A, is going to be, the red one's at 860. Okay? Check, baby, check, baby. We're good to go. That should conclude 16.5. Again, one last thing I want to comment on, and that is recall that if we have, the lower the number of multiples, the more overlap there is between the two data sets. Okay? So the smaller the MAD's distance, the closer the overlap is, the more overlap there is visually. The greater the MADs are, the more or the less overlap we actually have. Okay? And again, if you want to have a good picture of this in your hardback book, to be quite frank with you, on part 3 in particular. All right, see you.